Hello. Hope everybody's doing okay today. Just kind of getting myself set up here and taking a look at a lot of things. So a few things obviously in here have changed since last week. As you can see, we have a ridiculously stupid ender generation system. Although it is fully automated, I noticed that there was some issues with just the server shutting down, and when it started back up, it changed all the ticks where each tick happens in the chunk, and that caused some issues, not only in each chunk, but obviously going from chunk to chunk. So because it automatically feeds off the ender pearl farm, it was chucking them out faster than it could grow them. So now it's just as soon as it gets one, it seems like it's throwing it in the system again. I mean, it's putting out a pretty good amount. Most of these are set to very minimal loss, if any. Yeah. So about 512 a tick for each one when it's fully running, which isn't bad. It means that the problem is that there's a lot of idle time back and forth. So we're probably going to strip this down and go back to the standard, maybe 4 or something that's all within one chunk, just to try and speed up the process. Again, 4 is usually how standard one is. So we might do that to help maintain that. But the thing is, we're generating enough power that we needed somewhere new to store it, and that's what's up there. Let's go take a look at it real quick. This is from Draconic Evolution. It's energy core. You need these pylons to send and receive power from it. This is coming from the ender generating system. Here, every once in a while, you see just a little bit of power flowing out here. It's to actually maintain the dimensional transceivers. They do have a little bit of upkeep here. You see 10 RF a tick. Right now, we are in a tier 4. Holds 9.8 billion RF. You can see here, we haven't been doing too bad. I think until the server went down for routine maintenance this morning, it was generating at a pretty quick rate. As you can see there, the 6.4 billion RF a tick, which is pretty amazing. So today, I wanted to, before I logged on and realized all the power issues, I wanted to work on the RF tools, or the, the deep resonance power generation that we got going on here, so we can automate this. I've got a few ideas, and we can take a look at that in a second. I also had set up, for the Draconic Evolution, we need nether stars, which means we need to have a wither farm going, so I needed wither skeletons. And this was going pretty good. I made a few changes to everything. I had tried a couple different things, but we went back to the standard Ender IO. And I also, to control it, because every time we seem to leave it on overnight, it just kills the system. So I thought, oh hey, I got this all figured out, and I set up this wireless, or this redstone transmitter. And so what it's supposed to do is, so when this one is in charging mode, right, when it hits 10%, it goes into charging mode, it remits that redstone signal, right? It says, hey, we need something. So that's what it's doing here, is it emits the signal, then this inverts it, so it turns this off. right? So when it's not charging, this should be sending a redstone signal to here and turns this on. It also then sends a signal upstairs, but I misconstrued it. That red signal turns them off. So, so right now, unless I did something I didn't know about, which is very true, right? Because I think the redstone signal turns them off. I thought that's how that worked, which is why we had to invert it. I think. Or it needs a redstone signal to run. Right now, they are not running without a redstone signal. So, yeah. So I really goofed that up. So we burnt through the power again because I left the wither skeleton spawners running all night. I hope everybody can hear me okay. So then down here, we just put the, in my great wiring job here, I've got this redstone receiver here, same channel, sends out on here and then sends it up there. I also had a lever. I went through a whole bunch of stuff trying to get this, to figure out what was going on, so I tore out some of the extra wiring I had. Wouldn't be a bad idea to go through here at some point in time and revisit this, because we're going to have to get the wither stuff going soon. But before it did go out, we got ourselves a few, so we can get 10 nether stars if we needed to right now. So we definitely got some good things going for us. So this is pretty standard as far as the top side goes, right? We have these ender monitors set to pearl fired, and then it sends a signal off for what's already been charged here. So just running parallel circuits here. So the outside circuit's running 10 ticks ahead, or about a half a second ahead of the ender pearl. Now that we've got this fixed, are we at least starting to get a little backlog in here? Yeah, we are. So that farm should easily keep up with this. We were completely backstuffed yesterday. Let's see, I just threw some in here and I was trying to empty my inventory. Oops, darn it, and that's stupid. Andy. We have an extra 125 in here as well, so we're not doing too bad. So, what I'm doing, my biggest challenge with this was running the loop so that it wasn't constantly running the outside and it would reset. So what I've done here is I set a pearl fired from here. You can see that down there. And that's what comes up here and then does the loop restart. There's nothing that connects this one to there without it saying that it fired a pearl, at least down there. And then underneath here, let's see, so this runs into the sequencer so that it can restart the loop. Underneath here we have the timer, so that's what keeps getting reset every time it passes by that spot. And then if it doesn't get reset, it sends a signal off to get, should have done it right there, to restart another one. So it goes over this way, sets the timer for the countdown for the injector, and gets the outside running again. So that was my biggest challenge when I was running 4 of them, was that crazy loop. And now even with this, so now that I at least have an idea, you might be able to break it down into 4 a lot easier. So that's kind of the basics of what was going on here the last few days. A little bit challenging. Burnt through another crystal over here. Matter of fact, I don't know if we have another one ready to go or not. No, we have 30 here. So we want to get this automated as much as we can today. And we might be able to just come up with something that's going to work pretty good. last time we were streaming, we looked at doing what we could do to boost this as best we could. We were going to do nether quartz in one, and then gas tiers in the other, because that one caps out at 100, but with our strength and efficiency differences, that's essentially two nether quartz transactions, give or take a percent. Is it worth it to set everything up for the second lasering? I'm not sure, to be honest with you, but it's something I want to try. But my goal today is to automate all this stuff, and there's a few different mods we can use to kind of do this. The problem is moving things at a slow enough pace. And a lot of people I've seen have done a lot of different things. People will use the fluid monitors from, let's see, there is a fluid monitor somewhere here. Sorry, I'm looking over some chat things here. If you're watching, can you go ahead and post in there? Let's see who's all here. Let's see. So there's the fluid monitor from, I think it's RF Tools, or liquid monitor maybe, that's what it is. Let's see. Liquid monitor from RF Tools. They can kind of keep an eye on that. There's a lot of different things. One that's kind of got me kind of curious is RF Tools Control, where you're supposed to be able to use the control block, and I'm not sure how the rest of this all works. So that's an option. What do we got here? Some books for control manual. Redstone or a book. Maybe we'll just take a look at that and see if that's going to work out for us. Let's see. Sorry, got a couple things I'm chatting on as well. Trying to get a few things fixed. So we're after a book and some redstone. Book is going to be hiding out in here. I'll steal one of these, or two it seems like. We could even just grab our redstone from here with our wireless. I'd just be super lazy about it. We need 3 for that. That seem right? Nope. There we go. So this should give us some ideas of what we need. Obviously we're going to need the programmer. Need a program card. Moving items. Tank. A couple holding 4 fluid liquids. Okay, no current way to interact with the multi-tank except through the processor and a program accessing the fluids. This is meant purely as a directly accessible fluid storage for the processor. Plus, isn't so not useful. Okay. So maybe that's what we're gonna try today, is to work on this. So let's go ahead, slip through the walls here. And what was it? Control. Let's refine storage. RF tools looks good. Storage control module, space chamber. Let's just read our book again before we just programmer. Right, so RF tools controls is an added module for RF tools. Sorry, I'm reading the screen. I just don't think I need to read it to you. Okay, so the programmer is what we need first, and we're going to need a program card. So let's hop in here. Programmer. Of course, everything in here needs one of these. And we just threw that on the ground because we're special. Program card. Card. Well, what is this? Card base. We don't have the green stuff it wants. Cactus green. Well, it's been a long time since we've had to use cactus green for anything. It's not going to be in there either. Somewhere in our floral stuff, I bet. We got some cactus. We got some cactus green. So let's head back and make the rest of this. So, plop this in here. Alright, there's our card. Oh, we gotta remember. For some reason, because that arc is right there. So let's grab you. We're also gonna need that tank. Was that this one here, right? The multi-tank? Let's see if we can go figure this out now. So, we really want to work with these two things. Let's just break this. Oh, we can't interact with that spot we're in. There we go. So we'll just pop all this stuff off, because we're not using any of that. That's the liquid monitor that we're not going to use anymore. If we put the programmer here, and the multi-tank behind it. No, we're supposed to be able to put things on a card. And rather than having like a computer language programming in here, we have all these things that we can do over here. So let's follow along in the book here and see what we got here. Processor, device that actually runs your programs. We read it with the programmer and then insert that card in the processor. So we don't really need this here, do we? Let's just set that off to the side. We need a processor. This is why reading helps. We just kind of do this how we want. Let's get our mouse up here, type in processor, and our tools. Yep, that's the one we want. We're going to need more of that cactus green. We're going to have to cook up some more soon too. So let's just hop down here. I'm trying to think about whether we want to start growing more of it. I don't think there's any in here. And there's none in here. None in there. So let's do this. Let's grab our cactus here. Get that one cactus green. In order to get that, you need to smelt down some cactus. So before we go smelting all of our cactus down, let's go place some of it to grow on this sand right here. Does it have to be on the sand? Yes, has to be on the sand. Can't be touching anything else. 2, 3, 4, 5, 6, 7, and 8. Cook the rest of this up. So we swing through here. We'll fire this up quick. So now the question is, while that's doing that, did we sever something along the way, or is it still not powered up? It looks like it's trying to get powered up. Just hasn't reached that point yet. What we can do is help it along. We're going to dump these here. We don't need all that stuff. Now it should start taking these in and converting those into the seeds, creating more of the energy that we need to move things along. We could start bucketing this over. Probably 6 of one, half dozen the other, but speed and time. You know, I mean, at this point it's less about that and more about getting the canola taken care of. This is slowly going to be phased out of the system, I think. Just doesn't seem like it's going to be cutting it for all the stuff we're doing. So, as right now, that stuff in there is kind of our primary, tier or top tier for power gen. We're slowly losing everything else, so it's not helping. But here we're not doing too bad. Pretty good backlog on stuff, so we just got to find a way. We'll have to put in some high voltage wires to make this kind of like the backup or machine power or something like that. And I don't know what we're going to use all that power for yet, but I have an idea as how to generate it even faster, which will be nice in the end. Nobody says that there's too much power. So let's hop down in here and grab our cactus green, which we probably didn't need to do, because if we put it in there, it ended up home already. Let's go over here. Okay, let's see. We get up to about 17, 18. I think even at some points 19 k RF a tick. Right now it's just the delay on those ender pearls that's causing some of an issue. Last night we were running a lot better. so I think there's still some delay issues. But right now it's working, and I'm not going to complain about that. Alright, let me just hop over here to this chat real quick. Alright, so we needed about a processor. Alright, that's what we're going after. We need 2 of these green cards. Dump them back in there. Oh yes, the infamous machine. So if this does all the work, and this does all the programming. Alright, so we're learning networking. Using a network card and several nodes, you can create a network. Processor only has 6 sides, so using a network you can extend this by also enabling access to the sides of all the nodes that are connected to the network. Huh. Okay. I guess we're going to learn more about that as we go. After installing a network card, you need to set it up. Well, we're not that far. And crafting station is a device in which you can request items to be crafted through a program. No, we don't need that. Crafting cards, nope. A normal crafting device with an internal buffer for items. Supports piping out of the crafted result from the bottom. Addition, a running program on a processor can directly input ingredients for recipe in the workbench from the top side. The internal buffer of the workbench is often used for crafting cards to help with logic. Yep, okay. Alright, so the multi-tank is a block that's capable of holding 4 types of liquids. When placed adjacent to the processor, it gives that processor access to 4 new fluid slots, which can be allocated to programs so they can work with liquids. Note that there's currently no way to interact with the multi-tank except through the processor. Okay. So what about move items at some point? It's important to note that the processor cannot move items directly from one inventory to another. So I have to go through the processor itself. That's why you typically need fetch and push items after each other. So I'm going to try to do that. You need to insert a storage screen module. So sure you can leave the inventory parameter. Alright. I don't really need graphics. I have opcodes that are arranged on a grid. Opcodes connect to the other opcodes through a green arrow or red arrow in the case of a test opcode, and they can have parameters that can influence what they can do. The tooltip on the opcoded program will give you more information. Okay. Well, okay, so we have events, evaluations, test, operation, and hey look, there's even stuff for our deep resonance. Huh. Well, that's not what we were going to use it for, but redstone on, redstone off, event repeat, signal, GFX select, message. Well, I think we're going to say event repeat. It's asking for how many ticks. Let's say ticks between each execution. Let's say We know it doesn't take very long. We don't need it checking every time. Let's say every 10 seconds. Just only one. So just run. Okay. So now the next thing we need to do is every time we need you to examine a liquid. So open computer. Here we go. Huh. This may have gotten harder than I thought. So open computers, but here we get to RF tools, right? So we got this. Double click to change connector. Oh. So we can change it as we go. So let's see, just kind of learning this. So operations. We need to tank. Okay, so we need the east tank. Right, so we want you to check tank east. Optional side from which we want to access the given inventory doesn't matter. Right? Boom. Close. Check tank east. Next we need let's pass this. Huh, this is let's see, what do we got? Modulus. Copy the last return value to a token item. Slot. Okay. Let's see if there's something in here about programming concepts. Okay, so we looked at this, give you more information. Parameters and variables are typed. That means they have a specific type, need to be converted to be used as something else. Many conversions are done automatically. First, if we do a string, but the last result was an integer, then the integer will automatically be converted into a string. Yes, this would be a lot easier, just maybe writing it with an open computer. Multiple parameters which control how the app code works. They have a constant, a reference to a variable, or a function. If you open the parameter editor in the programmer, options, the list of functions, the type of parameter. Processor can start with 32 variables. Those are event driven. That means that they only start when some kind of event. Control when they are fired. Program sequence on a card will need at least one event, otherwise it can never run. It's possible to connect multiple events to the same program sequence. Event fires. Then, let's see, just going through there. And no, Mickle, it's not Tuesday. I normally stream on, it's been on Wednesdays before, and now it's Mondays and Wednesdays. Why? And yes, I don't read my chat. I'm trying to figure out what I'm doing. I have no idea. I jumped right into this. I'm trying to get one bucket of lava here when I need to. Or when it's less than, when it is less than 50%, we need to move one bucket of lava. And I have no clue how to do that yet. Just trying to pass variables, but I know we can make this a constant of 50. So if we pass this as the opcode result converted into an integer. Okay. So if it's less than that, this seems to... Okay, maybe we have something going here. Let's set this here for now. Alright. Yeah, comparators. I'm just trying to figure out what I'm doing. So I think this is gonna work so far. I just need to now find a way to fetch a liquid. Examine liquid internal. I don't really have that. Get liquid name. To specific. Okay. Well, this would have done all of our fun stuff before with liquid crafting, but I can't seem to figure out. So this is events, so we know we're not there. Salt items. Readable name from an item. RF in a machine. I don't need get mac. Get liquid in tank. Get the amount of liquid stored in a specific tank adjacent to the processor. Okay, so this is the wrong one to use. Amount of liquid stored, yes. U. Can I just drop that opcode, go here. Side. East. Right? Yes, so look here. And if you are, well, we don't care about if you're greater than, we want if you're less than. So if you're less than that, we need to find something that fetches the fluid. Evaluate fluid. I don't need evaluates. Tests. Operations. This is... Ooh, here we go. Fetch liquid. Tank. So this is from the west. Close. Amount. What do you think this is in thousands? Drop a bucket. I don't know if it matters. So we'll do that, and then let's get a push liquid. I'm sure these flashing things mean that I didn't do something right, or it needs something more than I know. Slot out. Does it matter? Well, here, let's get the... We know we want it then to go to east. I hope that's not a milliblock. It's okay. Internal for input. You can have it in 1. We'll tell you 1. And that's optional. So now we just need... Let's see. Stop program. Stop program. Call you green. You're stopped. You're stopped. What more do you need? Card name, let's call it DR. It's not gonna work, but let's see what happens when we shove it in there anyhow. Alright, well, I guess the only way to test this is to get us some resonating ore, which I might have a little bit of. So when you're less than 50%, so it should be moving now, right? It's got... Or am I in the right? Set up item and a variable allocation for this card. Oh my goodness. Okay, we might need to look at our book some more. Need a return? Like a while loop. No, I don't know if I need a while loop because... Here, let's pull this back. So if I'm... Every... every 10 seconds, if I did my math right, this event repeats. It's set, so it starts this every 10 seconds. So it goes here and says, look at side E. And get that value. Right? Get liquid in tank. Then comes here. And it compares. The first value is here. And then the second value is a constant. Oops. Right? And so if this is greater than, oh, I wonder if because it's, this might be in millibuckets. So this might have to be something closer to like 8,000. I still don't know why this is blinking though. That's probably what our issue is here, but okay, well, let's see here. Tank moving items, programming concepts. Yes. Okay, types, parameters. Type many parameters are optional, which is in the tooltip. Constant, a reference to a variable or a function. If you open the program editor in the programmer, you can select between these three options. The available list of functions depends on the type of parameter. Up to 32 variables. These are all typed, just like parameters. Make sure to allocate the variables to the card slot that you need them for. Allocate variables to the card slot. Maybe that's part of what we're having a problem with. Okay, so I don't know what this is. But right now it can have everything it wants because we don't. Events. Yes. At least one event. No cores are available. That we put a waiting list. Fires. That one is discarded if there are no cores available. Okay, we get that. Okay. We're not doing any of that. Can show single messages or even the contents of variables. Let's use the internal debugger. Okay, so this is not helping us any. We still want to know what the heck's up with this. Evaluate an integer and set it as the result. This is what's got me confused. I'm not sure what's going to be. Okay. This still is giving me a problem. Okay, these are obviously because there's nothing connected there. So this is sending something. Now it's fine. Let's make sure. Alright. Now let's hop over here and see that now that whatever is... And it's clearly less than 50. So it's not greater than... Did we forget that we needed to... Oops. Oh, that's still at 8,000, so... Get liquid in tank. I wonder... I wanted to... Where's that debugging stuff that can tell me... Why don't you just tell me what is there? Evaluate a string. It's this result. Can't you just... help me with debugging? Want to know what kind of number you're giving me. Get liquid in tank. Let's see. Not sure what I'm gonna do here. Let's see. Actually, RF tools, control, wiki. Let's see if that's gonna help us here. This is not a very helpful wiki. Let's see. RF tools, blocks, teleportation, logic, shields. Yeah, that's not offering us a lot of support either. So, I'd like to know what number we're getting here, because it's got to be something, right? Last opcode result converted to an integer. But we know that right now, if it's giving the thing, it's not. So this should be working. So let's do something stupid here. Let's just go way up here, right? We know variable 2 save. I mean, we're making every effort to make sure that this isn't. Right, use this in the program to write your programs and then insert in the processor to run. So we inserted it. It can only run on Core X. No, we don't care. Setup, item, and variable allocation. We gave it like everything. That's the internal tanks. Oh, we gave it 0 and 1. You don't need any of this then, I don't think. Debug. How about you start running? Does it need a little encouragement? It probably needs power. Hey, look at that. Alright. What are we running here? Enhanced. I feel really stupid after all that. And with how annoying this guy's been. God, you guys are dumb. Then again, what have I been doing right? I should eventually wall this stuff off. Let's do that. So now we have power. Yeah, I don't know if we need any of this stuff. Alright. You come on out. We need our stuff back before we keep falling in that hole. No, not gonna sneak that underneath there, but let's hop back in here. Let's take a look at this now. What if, well, in any case, no matter what it is, it should have been throwing negatives the whole time anyhow. But let's drop this down to 50. Close, save. want to change something else. Fluid optional, right? But slot. Internal processor fluid slot for result. You always go into 0. You always come out of 0. Okay, so we might have an issue where we can't access this. Put it up here. Oh, you know what? Is the RF? It's probably this. Let's pick these up for a second. Just in case. Processor down. Hey, look. Now, pick you up. Yeah. We've got power. This just doesn't seem to want to work for us at all. Alright, let's try something different. Let's grab... We still have some tanks from something else. We have a fluid tank here. And we know we've got one back here that we could probably get rid of at some point. Let's do some testing here. I'll pop down these fluid tanks here and here. We're going to grab our processor and we're going to set it here. Oops, there we go. Grab some power. I think everything else is configured okay here. Check the configuration on this side. Okay, since it's not asking what we want, let's stick with the lava. Right now, we just want to get the bucket from here to there. Let's hop back over here. I like this program, so we're going to hold on to this card. Let's go make another program card quick. We'll use it as our test card. Oh, I hate that. Program card. I love Applied Energistics 2. Just saying. Mickle! Hanging in there with me, trying to help me figure this out, man. Alright. Clear this screen. We're going to pop this one up here. That's exceptions. Event redstone on. Only happens. It decided it goes on. Only when it goes on. Only when it goes off. Repeat. Let's repeat. Only lets one run. Here, let's do this every 5 seconds. So I think that's right. Right now, every 5 seconds, I want you to set redstone. Optional name for the node. Up to 15. I want you to wait. $50 ticks. And then I want you to set redstone up to level 0. Save. Test. Okay. Maybe because we said end program the first time it fails it. I don't know. We'll figure it out. Except for what I'm going to do here now is I'm going to grab a... We should still have some lamp. So we're just going to try and turn this lamp on and off. That is not a lamp, by the way. Just saying. If you didn't know, that's not a lamp. There we go. Let's throw our test card in. This is not working. Maybe we're having problems figuring out our start point. Our operations. Okay, you normally don't have to do this manually except to break a loop. Okay, so we don't need to do that in the other program. There. That's supposed to work. It's the best of my knowledge, anyhow. Oh, this doesn't have any... Oh, which one is this one? Okay, let's take you out. Oh, it won't allow them because I'm using them on this one. So if I take these away... There's no tanks available. Okay, so let's just take you away for a second. I don't know, use what you need to. Turn on. Something's just not working right. There's got to be something to this that we're not getting. That because this one is simple. This is just every 5 seconds or whatever it is. Not even every 2.5 seconds. Send a redstone signal. I mean, it's clearly not sending it. I'm looking up some programs here. It just seems like his site just keeps circling around stuff, and I'm not understanding what.
Hello everyone, this is Direwolf20.
Oh yeah, it's Direwolf.
Spotlight. Computer's not with you. So then repeat. This can happen every 20 ticks. And if you want to see more details, you can just hold shift here over any of these items called options. Go ahead and figure out what's up. There's other ones like signal. Signal can see from our screen or from the processor console. Take a look at some of these in a bit. And then there's graphic stuff we can do, messages, crafting, etc. So we're going to do repeat. So how do we do that? It's really pretty easy. We take our event repeat, which again will tell the program to run every so many ticks. We just drag it on the board, anywhere you want. It doesn't matter. Okay? And you can see it here indicating event repeat, info, it's telling you that you need a couple parameters. So let's go ahead and take a look at that. So you can see down here, ticks is the number of ticks we need to execute. So we want this to run every 20 ticks per second. So run the program every 1 second, run it every 5 seconds, 100 ticks. So just click on this little dot here and we'll make it 40. 40 ticks will be every 2 seconds. The other piece of information you might want to give your repeat event is whether or not it should run only one at a time. What this means is something like, say, for example, if the program took 5 seconds to run, but you said run it every 2 seconds, should the program run again or the first time you're done, right? So this is an optional one. We'll say true, so it can only run one instance of the program at a time. So what we already configured is that every 2 seconds this program is going to run. It's not doing it. Remember I said we wanted to emit redstone signal? So we could scroll through the opcodes here and find stuff for redstone, or we can use these filter buttons at the top. If I tell it to filter on redstone, we're only going to see opcodes related to redstone. There's one here for reading redstone, which is to find out how strong and how whether or not redstone signal exists on a particular type of processor. And then we can also set redstone. So let's tell it to set the redstone. When I drag this onto the board here, you'll notice that the green line here has just changed to connect. This means that after this program is done running, or after this opcode is done running, it's going to execute the next one of the green dot connections.
Okay.
Some opcodes have multiple outputs later. But for now, what we can see is that after this opcode, which is run every 40 seconds, is triggered, it'll move on to the next one, which is Operation Set Redstone. You also see that this little blinking red light at the top of it. This indicates that the set redstone command has some important information that needs to be provided, and it hasn't been provided yet. What we can tell it is which side of the block to emit the redstone signal on, and what level. Both of these are required, and that's why this is blinking. So let's go ahead and configure it to emit on, let's say, the north side of the block. And we'll say a redstone strength of 10. Cool? Now, at this point, every 40 seconds, it's going to turn on the redstone signal and keep it. So the first time this program runs, it's going to do something, and it's just going to be on forever. So let's go ahead and make it so it turns off after a short period of time. For this, we're going to want the wait operation. this does is it says it just waits a certain number of ticks. So let's go ahead over here and we'll tell it to wait 10 ticks, which is about half a second. Cool.
I'm
So
not sure.
what we see now
I'm
is we've got
I'm
that
watching the direwolf video right now.
right. So after the redstone signal is turned on, it waits 10 seconds. And then we're going to tell it to set redstone. And this is going to again be on the north side. And we're going to set the level to 0 to be it off. Now we have what should be a pretty functional program. So let's hit save. We'll give it a name. Redstone.
Okay.
Great. All the information about this program has now been saved on the program card. Now we need a processor. But in addition to the processor, we're going to need a few other things. Let's place it down and see what the UI looks like. Alright, pretty interesting. First we're going to need to give it a little bit of RF power. Something that nothing has at all. Excellent. The first thing that you need to install here is the CPU core. You see that there are 3 here. The basic CPU core cannot handle one operation per tick.
Oh.
And what that means is one opcode per tick can occur. You can also get faster ones that can do 4 or 6
Ah.
per tick.
I figured it out. I'm really stupid. If there was ever an epic fail, it's when the IT guy realizes that he's screwed up. And doesn't have a CPU core to run his stuff here. So let's see. We just need a basic one here. Let's throw this card in. Let's grab ourselves a CPU core. Oh man. Alright, Mikkel, I feel bad now. I feel really bad. Alright. Let's just go in here somewhere. Maybe. Maybe this goes in here. Test. Now it's gotta go somewhere.
And those require a little bit more power. Typically a basic one should do you at least start.
And I should have put it down here.
At this point we're not going to use it because there's nothing we need it for, but we're going to get into the various.
Hey, look at that.
You can also throw some network cards in here, which we'll talk about later on the spotlight as well. So to get this program started, first we're going to need to insert our program block. This goes into one of the 6 slots at the top, meaning that processors can handle up to 6 programs at once. And if you want to be able to run multiple programs at once, you can install multiple CPU cores. Each CPU core can allow it to run 1 program at a time, and if you want to install more, you're free to do so. Especially if you wanted to configure this
Let's try. Let's pull this one out now. Let's push this one in. Ooh, no liquid support. That's what this is. Okay. No liquid support. Let's see. Is that what I need? Still, I like the heads-up display, but still getting no liquid support when it's trying to do 1, 2, huh? Yep. Well, let's pull that out. Clear this, pop this in, load this. Get liquid in tank side E. So it can't. It's not even. No liquid support. Well, we figured some of this out, so let's try and work this where it's supposed to be going. Let's pop you down here. Let's throw our liquid support on the back here.
Let's go ahead and insert the program card and see what happens. I'm going to find the north side of this block, this direction, and I'm going to get the redstone. Nice. Every 2 seconds it's activating for about half a second with the power of 10.
Come on, drop it.
The program is doing exactly what we told it.
Thank you.
If it didn't, then this problem would work. So Dara, this is great. You just created the most complex redstone timer known to man. Can we do anything else with this? Yeah, we can. Because there's a lot more options. Fun. Now, I'm not going to talk too much about the console yet, but we're probably going to look at it a little bit more in depth later on in the Spotlight. But I should let you guys know that if you
Let's
type
see.
console, you can see a list of commands that you can type into the console. For example, one of the commands named signal relates to the event signal over here, where you can tell it to activate the program from the console. So you would use the signal command to do that. You can also type clear console. Go ahead and clear the list.
We might also need
You can also
some
list out
RAM.
programs that are currently running, and you can see information about each of the CPU cores and what they're doing, right? So CPU core 0 is being used by that program, and it's currently in the delayed 2 state waiting for time to meet. There's also some more complex debugging you can do to make it so that it only iterates a step every time you type a command instead of running the program infinitely. We'll probably get into that later on in the Spotlight as we cover more debugging.
Let's see.
So as much as redstone is fun to play with, I personally like to demonstrate with the moving of items around. So let's say we want to move items from one chest to another. Let's see how we can do that with some basic programming. I'm going to go ahead and clear the panel.
That's not what I
Say
asked
that if
for.
you like your program and you need to edit it, you can always
Well.
drop it in there and hit load and it'll bring it right down. Pretty cool. So as long as you don't save over the program code, you can go ahead and easily retrieve any program code that's written. So let's create a new program that's going to handle item manipulation. And in this case, I want to go ahead and use redstone on. Basically saying that this thing is going to receive a redstone signal in order to operate. Again, we have the side of the network block. I'm going to go ahead and probably say that this should happen on the downside. Cool. So that is activated. And to make sure that this thing is ready to go, throw a button.
Slip out of here.
Great. Next up, we can specify, same old simultaneous. We're going to set it to true. So basically, it can only run once until the program's done before it's allowed to continue. So let's start with some basic code manipulation. Remember, any blue
Not that I think that's going to matter.
items will go ahead and get manipulated. So there's a ton of information we can do about
But we're still not going anywhere.
like the ones that are touching the processor. So let's do something like get number of slots. What this is going to do is choosing an inventory. Now, for now, we're just going to say 10. So there's 4 items in it, right? So this should write the number 6 to the console, and it did. The variable 0 is still 4. Suppose it's about to, but I really want to demonstrate this simplistically for those who might not be following along and others. So now we want to subtract inventory. So what do we want to do? We want to just say 10 minus whatever is in variable 0. So it's really simple. Variable 1 repeats number 10. And then we want to subtract whatever is in variable 0. Cool. So that should be 10 minus 4, we should get 6. And what we're going to do is store that in another variable. Okay? Operation set variable.
Okay, so let's try something a little different here. Operation set variable. And we're going to set variable one. And then we're going to use variable one here, and we're using this constant. We're not even sure yet what it's going to be. Let's go back to 8,000. Oh, yes, we get it. And it's still having a problem with this. Access. I don't think it matters, but God, I hate how this doesn't want to work. Save. Pull this one out. The shift click with that card is just horrendous. There is a way, apparently, that we can get it to tell us what is going on in the console.
So this case, we're going to want to use the
So let's hop back over here.
What this does is copy the last returned value to a specified variable. Okay, and it's pretty simple. Give it a variable. We'll call it variable 2. Cool. So let's go ahead and move these fetches right here for a moment. And instead, what we're going to do is write variable just in the demonstration. Okay?
Right to the
So our
console.
message is going to be variable index 0. Okay? So in this case, we're going to find out how many items are in the north inventory in slot 0, store it in variable number 0, and then write whatever's stored in variable number 0 to the console. Cool? So we can go ahead and save. And we're going to go from here and run the program. Error, missing variable. We haven't talked about variables or RAM. So let's go ahead and get settled with that. So we're going to need RAM chips in order to interact with variables. And simply inserting them into the processor like so is going to open up variables available. But you also have to allocate those to the program. So we're going to make variables 1, 2, 3, 4, or 0, 1, 2, and 3 available to the program to run. Now, when I go ahead and hit the button, it's going to write out the number 8. Because what happened is, looked at the stack in here, counted that there were 8 items, stored it in variable number 0.
No
See,
liquid
by the way,
support. I
when
still wonder if there's something an issue here.
program ran, that's what was
If
stored
it can
in
only be
variable
with the
number 0
multi-tank.
variable buckets in the console. Pretty cool.
Are we just having an issue where this needs to be a head one and this needs to be on it? I mean, it doesn't really say much to that effect, but I mean, something's got to work here. Let's put you down. Slam our processor down. Still getting the same thing. No liquid support. No liquid support. Let's see. It might. Let's see. Okay, thanks for the help. Is it just that is it me that's cutting in and out? Because I've been pretty quiet here and there, and not really talking. So, but having problems programming this machine here because it's not. We're giving it more than what it needs. I keep getting this no liquid support. It's having a problem reading this tank, which it says is the case. Looking at some notes here. Let's see. Well, let's see. One, it detects the liquid amount outside that node. Maybe we're trying to be too basic with this. Numbers, energy. Alright. Okay. Thank you for your help there. Let's throw this card back in here. Hit save for a second. And let's see. Now that we've moved it, it should... see? Still no liquid support. Optional name of a node in the network. We don't have an optional name. Let's see. I'm still trying to figure this out. This is just not... So wanted to note fluid doesn't work with blood magic. Okay, so... Damn, Chrome blocking my stuff too. Let's see. Wonder if there's a setup in here. Let's see. I'm just not having fun with this. This became more irritating than it was worth. Okay, if we have the processor, put the processor down. For right now, we're not going to care about the liquids. You guys can just come sit over here for a minute. We'll deal with you in a moment. I need a... how about a chest? Let's make sure we're even doing this right. Okay. Count the number of items that's just flooded or of a certain type in an external inventory. Okay. Boom. Inventory. West. Slot 0. And then why don't you... set variable 0. And I want you to do message variable 0. Okay. So that's working. So then if we throw like this, boom, it knows there's 4 in there. Okay. So that works. So then if we take you out and we say fluid stack and target slot. Semi-liquid in a liquid slot. It's a readable name. I think this is the one we want. So let's get rid of you. Now we expect... Whoop. Oh, we're not in slot though. Get liquid. Get liquid intake. It's internal. Okay, so let's say now you are west, right? So on side west, we'll take our test card, hit save here. Now, let's throw that in there. We should get no liquid support. Good. I don't have anything to break this. Okay, now that read that one. So we were doing something weird before because it's reading that now at 72. Okay. So we know we can get that far. So let's move this back over to this side. My guess is that it's having a problem with this drum. So I wonder if I just get another tank. Oh, I have so many up here I don't need, but let's just make another one quick. Maybe that's our problem. Tank. Okay. We have some pressurized fluid. Alright. So let's try this again. Let's see. It's going to be there, so we're going to pick this up. Put that there. You can go in. And you don't pump directly in. Okay. I can respect that. Which is why we're going to do this. You extract always. Boom. And we're going to pull you guys up. Oh, something got bright. Builder block processor. Plop the processor there. We'll grab this tank here. Now, let's look at... So we have this, right? Repeat. Get liquid in tank, set variable. But now we want to look at side east. Okay, and instead of doing this on test now, we're going to start doing it in DR. I'm going to save this. We're going to pop it out here real quick. And we're going to double check that this is still working. Whoa. Test. No, the wrong one. DR. Okay. Bingo. So we know you are there, so let's get rid of you. Let's run our test. And our test is going to first look at our variable 0 and compare that to a constant 8,000. Okay. And then let's, to make sure we're doing this right, well, let's try this. We did the fetch liquid, push liquid, right? We're going to fetch tank from the west. And we're going to take 1 bucket. Fluid is optional. Slot, you can have 0. And then you are going to go to, you're going to push to the east 1 bucket. from slot 0. I think we have it. Let's give it a shot. Save. And so if this works, we wrote it wrong. Yep. We need this to be if this is false. Missing internal fluid. Missing internal fluid at 4-1. Okay. So what at fetch liquid? Okay, so we are having problems. Do we need to fetch a tank adjacent to networked block? This is the amount. The fluid to fetch. Internal fluid slot for result. That doesn't make any sense. How is that not what we just said here? From the west, slide relative to processor or node for the inventory, right? So that's the west. If I can. So we get that, and we know it's coming this way now, so we've made progress. But okay. So we're at the point now where we need to figure out missing internal fluid slot. So either we didn't program the slot right. There we go. Oh, look at that. Okay, let's do something stupid. Oh, crap. Okay. Gotta make sure, because that can't go over 9,000 or our quality drops. But we may have figured it out. It might be working. There's the pure stuff down here. It's not moving because we stole the tank that was using to move it up there. That's okay. We may have something working. That's at a quality of 100. That's at a quality of 100. And there we have it. Look at that. I'm almost willing to stop that program and say, instead of, just to be on the safe side, Let's pull this out for a second. That bothers me. Let's let it go to 7,600. Oh crap. What did it do? Alright, folks. Well, we've overstretched our 2 hours for tonight, so I greatly appreciate you stopping by. As always, check us out. You can get subscriptions at epicfailure.bycraft.com, I believe is what it is. And get a chance to, if you're watching this later, go ahead, hit that like, share it, subscribe if you haven't already. It helps us out immensely. It's just one of those things where it's the community helping the community. So we always feel good about people looking over. If you have comments, leave them. Let me know how it's going on. I know this one was a little bit quieter because things just weren't going as well as we had expected. So I know that that kind of happens every once in a while. And let's see. So yeah, it's epic-failure.bycraft.net is where you want to go. You get subscriptions to play right on here. Matter of fact, you could be building right over here. Any spot around town here or anywhere else on the maps. All you gotta do is go ahead and get that subscription. But until then, as frustrating as it can be sometimes, right? We just do what we can. And always remember, it's a game. Have fun.